Hi friends, welcome to Sada Learning Hub. You are with me, Sadashivrao. In this video, we are going to learn association or relationships in Hibernate. See, first of all, I'm going to discuss about why relationship is added between the tables. Then only we are going to understand the relationships in the Hibernate. For an application, for an application is some data is permanently required for the maintenance. If you see in the some applications, the data is required permanently for the maintenance. We use it to store the data in the database table. Such type of data we are going to use data to store it into the database tables. If the data is related to the multiple entities is stored into the single table of the database, then there is a chance of getting data redundancy. For example, we have the two entities, doctor and the patient, and we are storing the doctor and the patient taken appointment in the table like the following. If you say, I will show you the one table, how the data redundancy is comes into the picture. Now, if you see my table, this is the one table. If you see, this is a table called hospital table. Now, in this hospital table, I'm going to store my doctor information and as well as my patient information. In that situation, the doctor information is going repeating. See, the doctor information, 101 doctor information is repeating three times. Now, but patient information is different. Now, if you see some of the columns is going redundancy. In that case, in this table, each patient taken an appointment with the doctor. The doctor details are repeated for multiple times. If you see 101 is repeated multiple times and 102 is repeated for multiple times. So there is a data redundancy problem. If you are implementing this type of relationship, this type of tables, now there is a redundancy data comes into the picture. To reduce the redundancy problem, we can divide the hospital table data into separate tables. Now, I'm divided the hospital table into the two separate tables. The first one is doctor table and the second one is the patient table. Now, the data redundancy problem is eliminated, but there is no relationship between the tables. Which doctor is treating as a which patient, there is no relationship between the tables. Now here the problem is the separated into the two tables, that is okay, fine, so the redundancy is solved. But there is a no relationship between the tables. There is no relationship between the tables, which doctor is the treating which patient, there is no information. For that, in order to add the relationship between the tables, we have an option. Then we can take the patient ID as a common column in the two tables. Now the data will be stored like this. If you see, I'm putting the relationship between the doctor table and the patient table. I'm going to take a patient ID into my doctor table. Now into my doctor table. In that case also, the doctor information is repeating, means duplicating. See, 101 is repeating three times, 102 is repeating two times. Now the column data is repeating multiple times, so it is a burden on the database. Now if you see in these tables, relationship is added between the two tables, tables, but still there is a data redundancy. If you see 101 it repeating three times and 102 is repeating two times. Now we can take a doctor ID as a common table, that is flop. Now I'm going to changing some other different relation. In this relation, I'm going to take it doctor ID as a common column for between the two tables. Now I'm going to take a doctor ID is a common column for the two tables. See, this is my doctor table and this is my patient table. This doctor ID, I'm going to take it as a common column in between the two tables. Now in this time, I'm able to eliminate the redundancy columns or redundancy rows. In the above table, the data redundancy is reduced and also relation is added between the data of two tables. Now I'm able to give the relationship between the two tables. My doctor ID is pointing to patient table of a doctor ID. Now the relationship is available in between the two tables. According to the above tables design, there is a referential integrity between the tables where doctor table is acting as a parent and a patient table is acting as a child. If you see, this is acting as a parent table and this is acting as a child table. Doctor ID column of a doctor's table is a primary key. I'm going to make it as this as a primary key, and I'm going to make it this column as a foreign key. Now I am successfully eliminated the dependency problems in the tables. Now in case of objects, how I am going to do. This is in case of database design, database tables. First I have a doctor table and patient table. All the data is mixing with one table. After that I am separated the tables. After separating the tables, there is no relationship. Now after I am making the relationship, I'm making the right relationship. In that time, I'm able to reduce the redundancy of the data. Now, and also my doctor as a parent table and my patient as a child table, I'm making the relation between the two tables. Now, for this that is for database design. Now, coming to the object coming to the objects, why relationship is required between the objects. If you see in the database side, why you are making the relationships, we are reducing the redundancy of the data and we are making the fast retrievals and all those things. But in case of why the relationship between the objects, in the application design, if one Java class is taken to store the data related to multiple entities, then the data redundancy occurs between the objects or occurs in the objects at the class. If you see, take it as the same example. If you take the hospital example, if you take the hospital example, the data is redundancing. Doctor ID, doctor name, and qualification. The data is redundant. If you take the hospital as a one Pojo class, every time we need to make the doctor ID, doctor name, and the qualification. See, that is a burden. For example, if a Java class called hospital, then for each patient taken an appointment, the doctor details are repeated in the objects. In the objects also, the doctor details are going to repeating. Now, in that case, in order to avoid the redundancy in the data of the objects of a classes, we divided the data into two objects by creating a two separate classes. For this, what I am doing, I am creating a doctor separate and a patient separate. Now I am creating only one doctor object. I am After that, what I am doing, the doctor object is binded to the patient object. The purpose of the division of the data is to avoid the redundancy and also to manage the data effectively by reducing the memory of the objects. And also, it is very clear, and also it reduces the memory of the objects. And also it reduces the memory of the objects. If you see in the previous slide, we are creating the two objects. We are creating the two objects. Now in the two objects, the doctor data is repeating. That's why I am making here to reduce that problem. I'm making the two Pojo classes. One is the doctor Pojo class. Second one is the patient Pojo class. I'm making the two Pojo classes here. Now the Dr. Pojo class is not data is not repeating. Why? Because I'm creating a one time I'm assigning to data to the patient by putting the relationship. To avoid the data redundancy in the hospital class object, we can divide the data into the doctor and the patient objects. This is about that's why we need the associations and relationships. If you see in the database side, we are making the relationship between the tables, and if you see in the object sides also, we are dividing the Pojo classes to reduce the redundancy of the data. That is okay, fine. Next, what are the different ways to relation put the relationship between the tables in the Hibernate. There are the four different techniques to put the relationship between the tables in the Hibernate. If the data is divided into the more than one class objects, if data is divided into more than one class objects, then the relationship between the data of the class objects can be added to four ways to call them. There is a four techniques are there to add the relationship between the tables. The first one is one to many relationship. There are the four techniques are available in the Hibernate. There are the four relationship techniques are available in the Hibernate. The first one is one to many relationship. If the see one to many relationship, if the data is divided into more than one Java class object, then one Java class object act as a parent and other Java class object act as a child. One parent has a multiple childs. One parent has a multiple childs. If the data is divided into more than one Java class object, then one Java class act as a child parent and another Java class act as a child. And coming to the second relationship, many to one relationship. In many to one relationship, a parent object is added to the child object to get the relationship. If you see in the one to many, we are adding the parent object to the child object, but coming to the many to one, we are adding child object to the parent. We are adding, if you see the, sorry, if you see the one to many, we are adding child object to the parent object, and coming to the many to one, we are adding parent object to we are adding parent object to the child object to get the relationship. That is about many to one. And coming to the many to many relationship, one parent has a many childs. Many parents has a many childs. Sorry, many parents has a many childs. Many to many relationship is a combination of one to many and many to one. See, one to many and many to one means we can make it as a one to many reverse. It is the combination of one to many and one to many in reverse means many to one. The next relationship is one to one relationship. Applying the one to one relationship with foreign key is nothing but many to one relationship means one parent and one child. It is nothing but applying the foreign key, applying one to one with foreign key is nothing but many to one relationship only. But foreign key should not allow the duplicate values. See here, foreign key doesn't allows the duplicate values. One to one with primary key is like one to one with foreign key only, but instead of taking a separate foreign key column in the child class to make the primary key column as a, of the child table itself as a foreign key column. See, one to one with the primary key is like one to one with the foreign key only, but instead of taking a separate foreign key column, we are making the child table to make the primary key column of the child table itself as a foreign key column. That's it we are doing. We are not creating a one more key, one more primary key column. That is about one to one. See here, there are the four different types of relationships are available in the Hibernate. The first one is one to many relationship. One to many relationship means one parent has a many childs. Second one is many to one relationship means many parents has a one child. And coming to the third one, many to many relationship, many parents has a many childs. And coming to one parent has a one child. That is about the relationships in Hibernate. Next, I am going to discuss about each and every relation in depth, how to configure in XML, how to configure in annotation based by using all these relationships. If you want, just check with my coming videos. I will discuss how to implement one to one, one to many to one, and many to many by using XML configuration and as well as the annotation based configurations. Thank you guys. Thank you for watching this video. Please subscribe my channel, Sada Learning Hub. If you like this video, please click on like button. Thank you for watching.
Thank you so much watching this video. Hope this lesson helpful to you. Keep watching our lessons. Keep writing to us. Do not forget subscribe our channel Sada Learning Hub because we have many sessions that would help you to develop our skills, and I will be back soon. Till then you take care. Bye bye.